Hello everyone, welcome to the stream. So we'll basically discuss some calculus PYQs in this stream. Okay. So let's get started. I can wait a moment for if anyone basically wants to join, then we can get started. So this is basically JEE 2025 and PYQs for that. So it's basically for JEE 25 and PYQs from I think from 1990 to 2024. And the topic is right now derivatives. So we are going to solve derivatives PIQs from past year IIT problems. Let's do this one first. So if g of x is equal to minus root over 25 minus x square, then we basically need to find the value of limit x tends to 1, g of x minus g of 1 divided by x minus 1. Okay, this is one of the past questions that was asked in JEE Mains, and this is a pretty simple one, but it's very essential to develop the concept for this question. Uh, yeah, hi. Hello, Someshwar. So basically, this is the question, and this is our first question today, and I will explain it in complete detail. So I will assume basically that the viewers who are watching this, they want to know it from completely scratch. So g of x is minus root over 25 minus x square, and we need to find the value of this limit, which let us call it L. Okay. Okay. So this is the limit we have in hand. Now, first of all, I would like to say two things here. We can do it obviously using normal rationalization, but a better way of doing is this. A definition in this regard is very helpful. F dash t for a function which is fx is defined as limit x tends to a f of x minus f of a divided by x minus a. This is the definition of limit. Okay. Now, this limit definition basically leads to f dash of a, where f dash a is simply the derivative of the function f at the point a. Now, if we look at this function here, this limit here, g of x minus g of 1 whole divided by x minus 1 and x tends to 1. You can compare it with this definition where a is basically 1, your function is g of x, and everything else matches, correct? If that is the case, our required limit is nothing but g dash 1, which is derivative of g at the point 1. Now, first of all, what is the derivative of g? The chain rule tells us that this derivative can be evaluated like this. So first of all, root x is 1 by 2 root x, which we can write like this, 1 by 2 root over 25 minus x square, multiplied by the derivative of 25 minus x square, which is nothing but 2x minus 2x. And therefore, the limit, the required limit, should be equal to this thing at the point 1, that is obviously minus minus 2x. So 2 into 1 divided by 2 times root over 25 minus 1. Cut off the 2's, you get 1 by root over 24. So, okay, this should be your final answer. And you can simplify it. So basically, root over 24 is nothing but 4 root 6. So it's basically 2 root 6. And if you multiply it by root 6 up and down to rationalize it, it simply becomes root 6 by 12. Anyway, so this is your answer. So this is the first question here. Okay. So let's move on to the next one. Okay, so the next question here, we can do another very similar one. Suppose that f of a is equal to 2 and f dash a is equal to 1. And we are also given that g of a is minus 1 and g prime of a is 2. If you have all these values given, then we need to find the following limit. Limit x tends to, this is a very common question actually. You will even find it in your boards. There's a high chance this question comes in the boards. Minus g of a into f of x by x minus a. Try not to use the L'Hopital's and then do it. Well, using L'Hopital, obviously, this is very easy because you simply can check that this is 0 by 0 form by putting in the value a. You can write limit x tends to a. Differentiating above, we get g prime x into f of a minus g of a into f prime of x, which simply gives you the value. Let's write it here. G prime of a into f of a minus g of a into f prime of a. So this is our limiting value. And you can put the values in and we can simply get the answer as 2 times 2 minus 1 times 1, which is 2 into 2, 4 plus 1, which is, this is our required answer. So this is the second question for today. And again, a fairly simple one. But again, this type of questions are repeated very much in JEE Mains, and you need to be able to do them very fast. So that is why do not neglect these problems as well. So let's go to the third one. Okay, so let's do this one. So let f be a function from real numbers to real numbers, like this. And this function f, this satisfies two properties now. So first of all, f1 is 3 given, and it's also given that the derivative of f at 1 is 6. So these are the information you have, and you have to again find this limit. Limit x tends to 0, f of 1 plus x by f of 1 and whole to the power 1 by x. You have to understand what is the value of this limit. Okay, so this is the limit you have to find basically. Actually, let's begin doing it. Let this limit be L. And if you take logarithm on both sides, log L should be equal to limit x tends to 0, 1 by x, logarithm of f of 1 plus x by f of 1. Now, why did we take logarithm? Whenever you see an exponent, and the exponent basically is a variable, we are obliged to take logarithms on both sides. So assume the limits as something and then just take logarithm. So that whenever you evaluate the limit now, whatever value comes out, you will get the value of log of the limit, and from which you can easily get the value of it, right? This is much easier to deal with. So limit x tends to 0, 1 upon x, log of f of 1 plus x minus f of, by f of 1. If you were to do it further, you can write limit x tends to 0. Now use the property of logarithms, which is log of a by b should be log a minus log b. Therefore, this should be log of f of 1 plus x minus log of f of 1 divided by x. Okay. So this is your limit basically. Now, in this format, if you were to see that what is this function, you can understand again from the definition that we had defined before. If you have a function called g of x, which was equal to log of fx, then according to the definition of the derivative, this again could have been written like that. So, okay, first let us check what's the f of 1 and stuff like that. So, first of all, if you put x equals to 0 here, if you put x equals to 0 here, what do we get? Do we have a limiting form? So, x equals to 0 log f1 minus log f1, which is basically 0, and then you have a divided, which is also 0. So, this is indeed a 0 by 0 form. And if you have a 0 by 0 form, then we obviously can do L'Hopital effect. Hi, Aramaru. Matrices, right? Yeah, actually, we'll actually do derivatives for this session, and matrices, I think I will do a sneak peek into this session, and then probably I will schedule it for tomorrow. Okay, so like we will go side by side with algebra and calculus, and then we can do them parallelly. And once we're complete with those, then we can, I think, move on to topics like probability and statistics. That should be fine, right? Okay, so you have limit x tends to 0, log of f of 1 plus x minus log of f of 1. For anyone new to the stream, this was the question. If f is a function from real to real, and f of 1 is 3, and f dash 1 is 6, then we have to find the value of this limit. These are one of the PYQs that came in JEE Mains. I think this was a JEE Main problem. It doesn't look like a JEE Advanced problem. Anyway, so we can again apply lambda here. And once we do that, we would get this. So denominator would be 1, so we will not write that. Log of f of 1 plus x, the derivative of this should be f of 1 plus x. And in the numerator, f prime of 1 plus x. Now you can simply put 0 and you can get the answer as f1 by f prime 1 by f of 1. You can put the values. F prime 1 is 6 and f of 1 is 3. So this would give you 6 by 3, which is nothing but 2. Therefore, L should be equals to E square because the base of logarithm is E. So L is basically E square. Okay. Yeah, we are going to study integration because this session is kind of like calculus PYQ. So we'll study both integration and derivatives actually. Okay, so this is L equals to E square. So I think this three examples of limits, if you are new, you can just go back and watch from the beginning. I have given three examples of PYQs here, and all three depend. So these are the questions that you will get asked for derivatives, okay, in the session, in your exam. So these are the questions that you have to look out for. Okay. So let's do an interesting question actually. Let's do number 4, 0 to infinity, e to the power minus 2x, sine of bx dx. What is the value of this integral? This is what we are going to do. So this is again a very one of the famous standard integrals, which we can do either by using real analysis, or we can also use some complex forms here. Like, let's say you can use the Euler's form, like e to the power ix equals to cosine of x plus I into sine of x. So this is a formula you should remember. And this problem can be done in multiple ways, basically. Yes. We will also do a lot of PYQs actually. Actually, these questions I've already selected before, so I'm going to basically do them. And if you have any additions, you may actually post them in the chat. I will also do and explain those questions as well. But this is the basic idea: 0 to infinity e to the power minus 2x sine of bx dx. This is basically the integral. Okay, so if you name this integral as IB, because well, the answer you're going to get is going to be in the terms of b, right? So let b be a variable. Why not? So okay, so let's do this first of all using this sine of bx. If you understand if you understood this Euler's formula, sine of bx is simply imaginary part of sine, basically not sine, e to the power I bx. Okay. So sine of bx is the imaginary part of e to the power I bx. This comes directly from this Euler's formula, where you can see that imaginary part of e to the power ix is sin x and the real part is cos x. Correct. So if you want to evaluate this in a very straightforward way, you can simply do 0 to infinity. And instead of sine of bx, you can simply write imaginary part of e to the power minus 2x into e to the power ibx dx. And this would mean that this is imaginary part of 0 to infinity e to the power. And if you take minus x common, it simply gives you minus 2 of ib dx. Okay. Now, this is a very standard integral, but you should also remember it by heart. If you have 0 to infinity e to the power minus px dx, where p is a real number and p is greater than 0, if this is the case, this integral always equals 1 by p. You can directly prove it using the definition of the antiderivative of e to the power minus px, but still just remember it as a fact. Using this, you can write the integral, required integral, which was imaginary part of this, as imaginary part of 1 by 2 minus ib. And this would give you imaginary part of multiply by the conjugate 2 plus ib up and down 2 minus ib into 2 plus ib. This would give you imaginary part of 2 plus ib divided by this one becomes 4 plus b square, right? And the imaginary part we can clearly see now, it's b by 4 plus b square. So b by 4 plus b square. So in general, we have the value 0 to infinity e to the power minus 2x sine of bx dx as b by 4 plus b square, which is the required answer. Okay. So we can have a quick recap of what we did. So this was the integral concerned, IB, which is equals to 0 to infinity e to the power minus 2x multiplied by sine of bx dx, where b is a real number, not equals to 0. And once we get that, we used Euler's formula. So this is Euler's formula. We use this to get e to the power ix equals to cos x plus I sin x, and then we wrote sine of bx as the imaginary part of e to the power ibx. And using that, we transform this integral ib into imaginary part. We just replace sine of bx with e to the power ibx so as to get the whole integral in terms of an exponential, and just wrote minus x e to the power minus x whole into 2 minus ib, where 2 minus ib is simply acting as a number. Now, this integral where 0 to infinity e to the power minus px dx is there, and you can simply say if mod p is greater than 0, where modulus of p is basically what I'm meaning, then the answer is basically 1 by p or 1 by mod p, whatever you can see. And using this, we can transform this integral into this form, right? And once we do that, we have this has imaginary part of, after multiplying the conjugate 2 plus ib up and down, we can simply get this, where you have the answer finally as b by 4 plus b square. Correct? So this is your answer. In a similar way, you can also do the cosine part of the same series. Okay. A fairly connected integral is this one, 0 to infinity sine x by x whole square dx. This is an integral, which is again one of the famous integrals that we have usually. Hi, about Obotify, and hi, introvert. Hi, everyone. Hello, everyone. I see there are a lot of like 9 people, I guess, here. It would be good if you guys can say like hello in chat and stuff, so we can interact, and is there a simpler approach for this question? This is the simplest approach, I would say. The approach for this, are you talking about the e to the power minus 2x sine bx one, or you're talking about this one, basically, this new integral, number 5? Are you talking about number 5, or are you talking about number 4, is what I'm asking. So for number 4 here, so basically for e to the power minus 2x sine of bx dx, this integral, This is the simplest approach, and there are no approaches which are simpler than this, if I may put it that way, because this integral can be solved by by doing the reduction formulas. Yes, yes, fourth question. Okay, this can be done using reduction formulas, where you have to do IBP twice. You can do the indefinite of this one. But once you apply the e to the power IBX wala formula, you can directly get your answer. So this is like a very standard hack in integrations where you have sin x there. Okay. Okay. So now let's get on to this one where you have, let me write it clearly here, 0 to infinity sin x upon x whole square dx. So this is the integral we are going to do. And for from tomorrow onwards, I would actually schedule the stream. And this stream would be basically, I would also give you details of what the stream is going to be about. What are we going to discuss? Will there be any doubt sessions, or some sessions where you give me questions and I solve it for you and explain them? So I would explain that in a community post. I would post that by tonight. And I guess we will have a stream tomorrow where we can discuss all the important questions and again clear doubts of people. So for today, let's do this integral and end the stream here. So 0 to infinity sin x by x whole square dx. Now, what I'm only going to say is this integral can be reduced into the following integral. 0 to infinity sin x by x dx. So this can be reduced into this following integral. And this basically is a way to, there is a way to reduce that, and that is using IVP, integration by parts. And once you reduce it to this integral is again not very hard. You can write this as 0 to infinity sin x. And this 1 by x dx, you can write it as 0 to infinity e to the power minus xy dy. Where in this integral, x is acting as a constant. And then since these integrals are convergent, and we can prove that it is legal to interchange the integration and signs here. So we will do that, and we will get e to the power sin x into e to the power minus xy dy dx. Okay. And once we get that, we can write this as 0 to infinity, 0 to infinity, and wait, e to the power minus xy into sin x dx and dy outside. So we are first going to do the x y integration. And you just saw that how we do this integration, where right now y is acting as a constant inside. Once you do that, you will get basically, I think, 1 by 1 plus y square dy. And this is nothing but tan inverse of y. There's a video of me solving this sin x upon x integral. It's called the incredible integral of sin x upon x, I think. You can search it up. So I have explained it in details there. So the answer is basically tan inverse of y from infinity to 0. This basically gives you tan inverse of infinity, which is nothing but pi by 2. And thus your final integral is equal to pi by 2 as well. Now this reduction can be done by IBP, and this is a standard exercise. I would, yes, pi by 2 is the answer. That is correct. I would ask you to try and do this IBP. But do not be fooled, because sin x by x is like 0 to infinity sin x by x is pi by 2, 0 to infinity sin x by x whole square is pi by 2. Do not think that sin x by x whole cube is also going to be pi by 2. So this is not pi by 2, and you can try it as an exercise to find the value of this on your own. And if you're interested further, you can go ahead and try sin x upon x whole to the power n for any positive integer n. You can try both of these sums. Both of these sums are like, well, very hard, I would say. And obviously the latter one is very hard. You can send me questions through mail. I have my mail given there. And also in the description, I have a form for the JEE crash course and the ISI crash course I have. And also there is an integration crash course going on, learning all these different types of integrations and stuff that in examinations or maybe higher. You can check the description if you want to apply for any of these courses, which would be mentored personally by me. But do that only if you're serious about it. Otherwise, live streams and videos are enough. And otherwise, okay, so you can send me questions through mail, is what I'm saying. So all of you guys can send questions, and obviously, I would solve them, and we can have a video on the solved questions. Okay. Hi, Shivam. Hello. So this question was clear, right? This 0 to infinity sin x upon x whole square wala question. So we did a lot of like 5 questions of PYQs. This was not necessarily a PYQ, but well, it was related to that. Hello, Shivam. Hello, hello. Okay, so I would end the stream basically today within a few minutes, and from tomorrow we should have like 1.5 or 2 hour streams where we can discuss things in depth. So check out the Google form that is linked in the description to apply for the batches and to send me questions or any doubts. You can find my email or Instagram. You can go to Instagram and text DM me there. And well, stay tuned for the videos. The videos upcoming would be based on problems and concepts. They would be short ones, but they would be to explain all of this. Okay, so yeah, bye. I guess. Have a good night.